Howdy. In this video, what we're going to do is we're going to talk about limits, okay? Especially now that we're in Cal 3, it's going to be slightly different, but kind of same thought process as back in Cal 1. Now, as a reminder, back in Calc 1, the limit as x approaches a of a function existed if and only if the limit as x approaches a from the left equal the limit as x approaches a from the right. And so, back in Calc 1, we had, a function like this, and we check limit from the left, limit from the right. We were only going in one dimension. We were only looking whether x is coming in from the left or the right side. But now it's a little bit different because I had a two-dimensional function back in Calc 1. Now we have a three-dimensional function here in Calc 3. And so what's going to happen is the limit as xy approaches AB will exist if along every possible path to AB goes to the same point. Now, what do I mean by paths? What I mean is, let's say I'm looking at the point 0, 0. Since this is a three-dimensional function, I have to look at all possible two-dimensional paths. So I can go maybe along the x-axis, or maybe I can go from y equals x, or maybe I can go from like y equals x squared, or maybe I can come up from the y-axis and so forth. Before, since there's only one dimension, it's either left or right. But now we can go in from a lot of very different paths. Varied different paths. And so what we're going to have to do is show that if it's a different path and they go to different limits, then the limit doesn't exist. Okay? So let's run through a couple of examples. One where the limit does exist and one where the limit doesn't exist. So let's take a look here at number 1. For number 1, I'm going to do the limit as xy approaches 2, 2 of x to the 4th minus y to the 4th over x squared minus y squared. Well, what I can do is I can actually factor this top. And so the limit as xy approaches 2, 2 of, well, I can factor x to the 4th minus y to the 4th as x squared plus y squared times x squared minus y squared all over x squared minus y squared. And if you notice, those x squared minus y squareds cancel. And so what you have is the limit as xy approaches 2, 2. With these x squared minus y squareds canceling, all I'm going to be left with is x squared plus y squared. And now when you plug 2 into x and 2 into y, I have 2 squared plus 2 squared, and 4 plus 4 is 8. Cool. But let's take a look at number 2. Number 2, I really can't factor that out in order to cancel stuff. And when I plug a 0 into there, it's 0 over 0. Can't really do L'Hopital's. L'Hopital's is only for, one variable functions or one variable limits. And so what we need to do is start to check each path. Okay. So there are different paths that you can take to get to the point 0, 0. The first path that I'm going to try is along the x-axis. And so if I go along the x-axis, if this here is my path, this is the function y equals 0. And so going along that path, if I take the limit of x0 approaches 0, 0, basically replacing all my y's with 0, I'm left with 0 over x squared plus 0, which is just going to output 0. And so the path from y equals 0 will output a 0. But what if I tried a different path? What if I tried the path like this? What if I went out like this? And this is the path x equals y squared. Or y equals square root of x, same thing. But I'm going to do x equals y squared. What if I went along that path? Okay, then I'm going to take the limit. And then x I'm replacing with the y squared. Y I'm just leaving as y. Approaches 0, 0. Well, replacing every x with a y squared, I have y squared times y squared over y squared squared plus y to the 4th. On top, you get y to the 4th. On bottom, y to the 4th plus y to the 4th is 2y to the 4th. And when that simplifies, that comes out to 1/2. And so therefore, since along one path it went to 0, along another path it went to 1/2, therefore we can say is that the limit as xy approaches 0, 0 of the xy squared over x squared plus y to the 4th, this limit does not exist because you went to different z values depending on which path you took to get to that point.